Who was Pythagoras? Pythagoras was an ancient Greek philosopher who lived around 500 BCE who believed numbers were the universe's mystical building blocks. He gets all the credit for the famous right-angled triangle theorem, but here's the catch. He never wrote anything down. His followers passed his teachings along entirely by word of mouth. He was basically a mathematical cult leader. To make history wilder, he wasn't even the first to figure it out. Centuries earlier, scholars in India recorded the exact same relationship between a right triangle's sides in manuals called the Shulba Sutras. So Indian mathematicians actually published the math, but the Greek guy who wrote absolutely nothing down gets his name on the theorem forever. I guess Pythagoras just had a way better social media presence.
If you like triangles, like and subscribe.
Now over to Mr. Forler for the rest of the lesson.
I can't believe Pythagoras has so many more followers than I do. Man, I gotta get myself a theorem. Sum of squares, also known as Pythagorean Theorem. We're going to start with a little refresher on some terminology. We're going to be talking about right triangles or right-angled triangles. That's a triangle that has a 90-degree angle in the corner. So when you see that box there in the corner, that's telling you that it is 90 degrees. And you probably remember the term hypotenuse, but in case you don't, the hypotenuse is the side of the triangle that is directly opposite the right angle. It's the longest side of a right triangle. You can see in this diagram, there's the 90-degree angle, and directly across from it is the hypotenuse. Get another example, same thing there. There's the right angle, and directly across from it, the longest side, that is the hypotenuse. And finally, there's your right angle, directly across, there is the hypotenuse. Pop quiz. Which of these figures have the hypotenuse identified? So, in other words, which one is the colored line indicating the hypotenuse? Take a moment, pause the video, and see if you can figure it out. Then come back and see the answer. Okay, so let's take a look. There's the 90-degree angle, and directly across from it, there's our hypotenuse. So we can say that that one is definitely the hypotenuse is identified by the color. What about this one? There's the angle, which means across from it would be the hypotenuse, but they've shown the line that's adjacent to it. So if it's adjacent to the 90 degrees, then it is not the hypotenuse. We've got the 90-degree angle, and directly opposite from it is the hypotenuse, and that is one that they've got indicated. So we can say that this one is also the hypotenuse. Letter F, there's our 90. Directly across from it is the line, and that's the one that's colored in. So we can say that that is also the hypotenuse being indicated. Next one, got the 90 degrees, but across from it is not highlighted. That one's adjacent, so that is not the hypotenuse. Same thing here, we've got across from it, but what's across is not highlighted. This one's adjacent, so clearly that is not the hypotenuse. Same thing here, the line is adjacent to it, so it's not the hypotenuse. And finally, 90-degree angle, and again, the highlighted line is adjacent to it. It is not across from it. So there's the hypotenuse, there's the hypotenuse, there's the hypotenuse, and there's the hypotenuse, and there's the hypotenuse. Now we're going to take a look at how we actually come up with the sum of squares and exactly what the Pythagorean theorem told us to do. So first of all, a quick refresher on calculating the area of a square. We take the length of one side and we multiply it by itself, or we can say that is s squared. So what this diagram is showing us is that we've got a triangle where one side is 3 meters, one side is 4 meters, and the hypotenuse, which is across from the 90, is 5 meters. And the question they're asking is, how do the areas of these two smaller squares relate to the area of this bigger square? Let's investigate. So this diagram has been turned around a little bit, but it still has the 3, 4, 5 side lengths. So on this side, it has a length of 3. So we put a square on there that is 3 by 3. This next side has a length of 4. So we put a square on it that is 4 by 4. And finally, this side we said was 5, and so it's 5 by 5. So you can see each of these is in fact square. It's got 4 by 4. Now what you should notice is that the area of this first circle would be 3 by 3. And if we add that to the area of the red square, that would be 4 by 4. So let's take a look at what that works out to. That's 9 plus 16, which is 25. And coincidentally, if we look at the third square that was on the hypotenuse, it had a length of 5 multiplied by 5, and that coincidentally is 25. So what we've seen is that if we take the length and we multiply by itself, in other words, we square it, we add that to the square of the other side of the other length here. If we add those two things together, we end up with the same amount as if we squared the hypotenuse. So remember, this only works for right triangles. You have to have that 90-degree angle in the corner. If you don't have that 90-degree angle, it's not going to work for you. Instead of using h for the hypotenuse, we typically just use a c. So we've got c squared is equal to a squared plus b squared. So there's our c, our a, and our b. Where this becomes most useful then is in actually figuring out then what is the value of c. This equation is giving us c squared, which is only so helpful until we go the final step and take the square root. So that means c is equal to the square root of a squared plus b squared. So you can do the calculation of a squared plus b squared first, and then on your calculator find the square root of it. That equation can also be rearranged, as you see down here, to get the a all by itself. We started with a squared is equal to c squared minus b squared. So we've just rearranged this original equation, and to get the a squared alone, we moved the b squared over to the other side. In doing so, we changed its sign. So we ended up with the c squared minus the b squared. And then if we wanted to go that final step again, that means that a is equal to the square root of c squared minus b squared. Let's look at a couple of examples here. Pythagorean theorem tells us that c squared is equal to a squared plus b squared. In this triangle, that gives us 3 squared plus 7 squared. That's 9 plus 49, which is equal to 58. That means c is going to be equal to the square root of 58, which you would do on your calculator, and you would find is 7.62 if you round it off to a couple decimals. Let's look at the next one. C squared is equal to 2 squared plus 6 squared. So that's 4 plus 36, which is equal to 40. That means c on its own is the square root of 40, which is equal to 6.32 if you round off. And then the third question, this time we're given the c value, so we're given the hypotenuse, but we're missing one of the other sides. But that's okay. We know that we can start off with the same equation. C squared is equal to a squared plus b squared. If you remember how to rearrange it, that's great. If you don't, you can always go back to the original equation. We've got c squared is equal to 9.9. That's going to be squared. Is equal to a squared plus b squared, which is 6.5 squared. So 9.9 squared is 98.01. 6.5 squared is, so we've got a squared plus 6.5 squared is 42.25. We want to get the a all by itself, so we have to subtract that 42.25 from that side. So we'll end up with a squared on that side, and then this side will have 98.01 minus 42.25. So a squared is then equal to 55.76. That means a is equal to the square root of that, which means that a is equal to approximately 7.47. Okay, pause the video, try these questions on your own, then come back to see the answer. All right, let's look at the answer. Here we're trying to find the hypotenuse, so that's x squared is equal to 6 squared plus 8 squared, which is equal to 36 plus 64. So that means x squared is equal to 100. If we take the square root of 100, that means x is equal to the square root of 100. And hopefully you recognize that 10 times 10 gives you 100, so therefore 10 is the square root of 100. Now let's look at this one. This time we're missing one of the sides. So we've got the hypotenuse here. We've got one side, but we need to find the third side. So we can start with our regular equation of c squared is equal to a squared plus b squared. This time our c squared is given, so we've got 13 squared is equal to a squared, which we'll say is 5 squared, plus y squared. That gives us 169 is equal to 25 plus y squared. That means if we get the y squared alone, we've got y squared is equal to 169 minus 25, which gives us y squared is equal to 144. Therefore, y is equal to the square root of 144, and therefore y is equal to 12. Now this last question here is a little bit tricky. First of all, it's showing us we've got one triangle here. It's got the two sides, but it's missing the hypotenuse. Once we find the length of the hypotenuse, that becomes the side of this other triangle. So we have to find that hypotenuse side first. That gives us another side, which we can then use to use the Pythagorean theorem a second time to find the value of c. So in this case, we'll start off with h squared is equal to 4 squared plus 5 squared. That's 16 plus 25, which is equal to 41. Therefore, h is equal to the square root of 41. Now to find the c, we're going to say that c squared is equal to 2 squared plus square root of 41 squared, which luckily, when you square the square root of something, you just end up with whatever number's underneath the radical. So we end up with 4 plus 41, which is equal to 45. Therefore, c is equal to the square root of 45, which if you do that in your calculator, you'll come out to something about 6.7. Okay, now it's your turn.
I can't believe Pythagoras has so many more followers than I do. Man, I gotta get myself a theorem.